Hello everybody, welcome to a new episode of the Dissenter. I'm your host Ricardo Lopes and today I'm joined by Dr. Bernard Wood. He is University Professor of Human Origins at the Center for the Advanced Study of Human Paleobiology at the Columbian College of Arts and Sciences at George Washington University in the US. He is a medically trained paleoanthropologist. His research interests are all related in one way or another to a long-standing preoccupation with hominin systematics. His current research interests are phylogeny reconstruction, hominin systematics, dental evolution, evolvability within the hominin clade, and diet reconstruction. He is the author of several books, including Human Evolution, a very short introduction, and Human Evolution, a guide to fossil evidence. So, Dr. Wood, thank you a lot for taking the time to come on the show. It's a pleasure to everyone.
Well, thank you very much for asking me.
Okay, great. So, let me first ask you, because I guess that most people, particularly ones that are not familiar with anthropology or paleobiology, what is hominin systematics?
Basically, hominin systematics is trying to work out how many species and how many genera were involved in the part of the tree of life between the hypothetical common ancestor of modern humans and chimpanzees and bonobos. Mm-hmm. It's a little like looking at a play and trying to work out, you're listening, not even looking at a play, you're listening to a play on the radio, and you're trying to work out who's in the cast. How many people are involved? Some plays are just monologues with one person. Other plays involve a cast of 20. Other plays involve a cast of 10. And my job is to try and work out how many cast members there were between, say, 7 million years ago and the present. Mm-hmm. And the tricky thing is that there is a sort of a perception that because we are the only species alive today, then if you go back in time, there was always only one species alive then. Yeah. But if you went back 50,000 years or 100,000 years, there will be several species of our clade, of our twig of the tree of life, alive and thriving, and so the present is not a terribly good guide to the past.
Yeah, right. So, and do we know what was the first hominin? Because there's also that distinction that people make in anthropology between hominids and hominins, right? So to distinguish basically the great apes or something like that from the basically hominins, right? That is our clade, correct?
Well, when I was a student, we were taught that the human line was, we were a separate family, the Hominidae, and the great apes were a separate family, the Pongidae. Mm-hmm. Now we know that two of those great apes are more closely related to us than they are to the rest of the great apes. So it doesn't make any sense to distinguish us at the level of the family. Mm-hmm. And so now people, most people, I think, distinguish us at the level of the tribe. And so they would say that all the great apes, including modern humans, are members of the Hominidae, and then we are members of the tribe Hominini, and the chimpanzees and bonobos are members of the tribe Panini.
Mm-hmm. Yeah. And just to go back to my question, do we know already who was or what was the first hominin?
Well, there are some candidates. Mm-hmm. I'm a little sort of skeptical that we would be able to recognize the earliest hominin with the degree of certainty that I think some of my colleagues would like. And there are several reasons for this. One is although there are very obvious differences between us and chimpanzees and bonobos, the closer you go back, or the further you go back in time, the more likely the two tribes will be more similar. Yeah. And the other thing is that we would really like to be able to identify morphology, because that's what paleontologists have to work with. We would really like to be able to identify morphology, which we can be absolutely certain only occurred in the hominin clade. Now, one of the things that has happened since I've been in this business is that molecular evidence can now be used to resolve relationships or develop really quite reliable hypotheses about relationships. And that has demonstrated again and again and again that morphology is not always a good guide to relationships. In other words, similar morphology can turn up in different parts of the tree of life, and that's called homoplasy. And so I'm a little sort of skeptical that we will be able to identify the earliest hominin with any degree of sort of reliability. There are candidates. There is Sahelanthropus chadensis from Central Africa. From Chad, there is Aurorin tuganensis, and there is Ardipithecus cadaver. In my view, although there are some features in these creatures which resemble those in later hominins, it seems to me we should be cautious and maybe assume that they are homoplasies rather than assume that they are peculiarities of hominins.
Mm-hmm. Yeah, I understand. And what about our last common ancestor? I know that we haven't yet identified it, but if we were able to do it, what would be the kind of information that we would get from it? I mean, what would we learn in terms of our human evolution that we don't know from the knowledge or the information that we have now?
Well, I think what we would learn from it, if somebody could give us a certificate that it was the earliest hominin, what I would do is that I would be greedy and I would go back and say, could you show me the earliest panin?
Yeah.
Because we would need to compare the earliest hominin with the earliest panin. Because what you would be looking for would be to get a sense of, was this creature still spending most of its time in the trees, or was it spending more time on the ground? Was this creature, was its diet? What was its diet? What was the social structure, and so on and so forth? So you would like to know all the things that you would want to observe if you discovered a new species of primate. You know, imagine you went into the forest somewhere and you discovered a new ape. You would want to know all sorts of things about that new ape. What was it eating? What part of the environment was it using? What was its social structure, and so on? So you want to know all those things about this fossil. The problem is that unless the fossil record is good, then you are going to struggle to be able to reconstruct many of those things. And the other difficulty is that hominins are quite rare. And in most fossil sites, they make up around 1% of all fossil mammals.
Mhm.
And so you have to find a lot of antelopes and a lot of pigs before you can begin to say there are no hominins. And so even if you find them, they are going to be quite rare. So I think, one would just want to know the sorts of things that we want to know about any early hominin, even if it was the earliest or not.
Yeah. And what about the genus Homo? That is a genus that is part of our hominin clade. I'm asking you this because there are people today that say that the genus Homo started with Homo erectus, but then you also have that complication, I guess, with Homo habilis and other species like that. So, do we know where it started exactly?
Well, we've been thinking about this for longer than I would care to admit. And the first thing you have to do is to ask yourself what a genus is. In other words, why would you want to put a species in a different genus? And basically, it seems to me that a genus is a clade. It's a distinct twig of the tree of life, but it's also a grade. In other words, the genus has to be adaptively coherent. So the reason you put something in a different genus is because you think it belongs to a different clade, and you put it in a different genus because you think it is adaptively different. So its locomotion is different, or its diet is different, or whatever. And so what we're looking for the origin of the genus Homo is to try and work out what modern humans and Neanderthals and Homo erectus have in common, and then go back into the fossil record and try and see when you no longer find those commonalities. In other words, all the modern humans and Homo erectus and Homo neanderthalensis are all obligate bipeds. So would you make obligate bipedalism a criterion for the genus Homo? Modern humans, Neanderthals, and Homo erectus, for their body mass, all have relatively small chewing teeth and relatively small mandibular bodies. So you would go back into the fossil record, and as soon as you find something that you think has relatively larger chewing teeth and relatively larger mandibular bodies, you would say, this is no longer a member of the genus Homo. And so it's a mixture of objectivity and interpretation. My instinct is that Homo erectus is probably the first member of the genus Homo, if the genus Homo is going to be interpreted. If the genus Homo is going to be interpreted in a way that I think makes sense. In other words, we are looking at an animal with limb proportions much like ours. We are looking at an animal with a diet much like ours, and we're looking with an animal with a locomotion, and probably, we don't know much about hands, but probably a dexterity much like ours. But it's really tough, and I think, and I understand why there's a lot of debate and contention, but in the end, you have to stand back and say, what's the most reasonable hypothesis?
So we've been touching a little bit on this topic from the beginning of the interview, but a big problem here is also the way we classify different species and how we distinguish between them. So in terms of the hominin clade, what are some of the best criteria that people use nowadays to when they are deciding if they split between different species or if they lump them together and things like that?
Well, I think that this needs to be answered in the context of what evidence do you have available.
Okay.
And the problem is that the evidence that you have available is the fossil evidence, and for a whole bunch of reasons to do with taphonomy, most of what we know about every individual that's represented in the hominin fossil record is much more likely to know something about their teeth and jaws and their head than to know something about their limbs, because those are the parts of the body that are best preserved in the fossil record. So the question then needs to be represented as saying, if the only thing you knew was the morphology of the teeth and jaws and the skull, how well would you do if you went into a museum and the museum curator allowed you, for some crazy reason, to break up chimpanzee skulls and chimpanzee jaws and gorilla skulls and gorilla jaws into the smaller pieces that you find in the fossil record? How well would you do at recognizing chimpanzee species and gorilla species? And so basically what we do is use species differences in the taxa that are most closely related to modern humans, i.e. chimpanzees and bonobos and gorillas, and to a lesser extent orangs and obviously modern humans. And we look and see how much variation there is in each of the species that we know to be represented in those skeletal collections. And then we take that and we look at the fossil record against those criteria.
Yeah.
But of course the problem is that the museum collections that I work with are probably no more than 200 years old. So you're looking at variation in an instant in time. The problem is the fossil record for a species, a hominin species, may well cover 100,000 years or 200,000 years or 300,000 years or 500,000 years or 1,000,000 years. So how do you match variation through time and across a range with a skeletal collection in a museum, which may have been collected over quite a large range of West Africa, if it's a chimpanzee species, but was collected in really an instant in time. So the subjective part of this is, what allowance do you make for time? And frankly, all I do is make a good guess. I mean, it's not, as far as I know, there is no magic wand that you can wave that allows you to convert a skeletal collection of chimpanzees to a skeletal collection of chimpanzees over 1,000,000 years.
So that's, I guess, one of the biggest challenges in reconstructing human evolution. What are some of the others? What would you say are some of the others? I mean, when you look at the knowledge that we have right now about the hominin clade and genus Homo and things like that, and how we evolved over time, what would you say are some of the biggest missing links and missing information that we have?
Well, we almost certainly do not have a comprehensive fossil record of all the taxa that were represented in the hominin clade. And we don't have that because there are periods and there are regions where we have a very either no fossil record or a very limited fossil record. And so even though there may be a fossil record for a particular time and a particular place, if that fossil record only contains 40 mammals, the chances that you will have a hominin there, or the chances that you will be able to recover the fossil record of a hominin, even though it was there, are really very small. So what we spend most of our time trying to do is to come up with a comprehensive history of the hominin clade, knowing that we don't have all the evidence. And so that, I think, is the main problem of hominin paleobiology. How do you behave? People want answers. They want to know how many hominins there were. They want to know how they were related. They want to know how they were functioning. But we know we don't have all the evidence. And so the trick is to come up with with a series of hypotheses which recognize that the evidence base is incomplete. Now, what you have to realize is that there are some hominins. There is this notion that all the hominins are ancestors of modern humans in some way.
Yeah.
But it's pretty clear that can't be right, because 2 million years ago there were, at least 2 or 3 distinct hominin species, maybe more, and they can't all be our ancestors. Right. And there are hominins, or there are taxa like Paranthropus boisei, which is such a weird creature that there is absolutely no way that you would have been able to predict its existence if we hadn't discovered the fossils. It is so strange, yet it's pretty clear that it is more closely related to other fossil hominins, which are more likely to be our ancestors than it is to anything else. I guess it could be a member of a different clade, but I think even somebody like me, who is pretty impressed by amounts of homoplasy, would find that a difficult hypothesis to defend. So what we have to realize is that within this hominin clade, there are creatures that are really very strange. Paranthropus boisei had very large chewing teeth. The crown of your mandibular, of your first mandibular molar in your lower jaw is about the size of of the nail on your little finger. The first molar of Paranthropus boisei is about the size of the nail on your thumb. It's very large. Mm-hmm. Its mandibles are about 3 times larger than they would need to be if they were modern humans or if they were Homo erectus. So these are strange sort of creatures. Mm-hmm. So what you have to do if you're trying to sort of understand hominin evolution is you're trying to understand where creatures, what part of Africa, because I think it's pretty clear that at least for at least a couple of million years and maybe longer, Africa, or at least until 2 million years ago, and maybe 2.5 million years ago, Africa was where hominin evolution was occurring. You have to try and work out what was this adaptive radiation that led to all these species, and how did we end up with just one species surviving? Now, that's a tough sort of question. And the problem, another problem of hominin evolution is that we are looking at the fossil record at a level of detail that most other mammalian paleontologists don't look at. Mm-hmm. If you ask a mammalian paleontologist, they will identify species of pigs or species of antelopes. But in general, if you find a fragmentary fossil, you'd be happy if you can assign it to a tribe or, a family. But, we're down in the weeds here. We're trying to look at species differences. And that, I think, is tough. I think that pushes the tools of paleontology a lot further than they're pushed in by people who are studying other groups of mammals.
Mm-hmm. So let me ask you now. You referred to the fact that for a long time we evolved in Africa, and then we started migrating. When did that first happen? Was it with Homo erectus or before that?
No, my sense is that it was probably before that. But when hominins first left Africa, it always sort of amuses me, when did this occur? My guess is that the fossil record, the first fossil record of hominins outside of Africa, doesn't represent the first migration of hominins out of Africa, because there were probably many other migrations that got snuffed out because of disease or because of maladaptation. And so I'm pretty sure we are never going to know when hominins first left Africa. The first fossil evidence is liable to be sometime after the first hominins left Africa, just as the first fossil evidence of any species is liable to be sometime after the origination of that species, and just as the last fossil evidence of a species is liable to be sometime before that species finally went extinct.
Mm-hmm. Yeah. And so let's get closer to our species now, Homo sapiens, and talk a little bit about it and the relationship it had with other species that lived more or less around the same time. So there's a big question surrounding Homo neanderthalensis, or Neanderthals, as people call it in a shorter version, let's say. We know nowadays, I think, if this is still correct, that we have some Neanderthal DNA in us. So what do we know about the relationship between the two species? Did they cross over in some way, or and why did the Neanderthals go extinct? Do we already know the answer to that, or not?
Okay, well, let me start by saying I am not a Neanderthal expert.
Okay.
As soon as things look anything like modern humans, I lose interest. Okay.
Okay.
So, but my understanding is that, sure, we do share DNA with Neanderthals. There are various reasons why we might share DNA with Neanderthals. One is that we might interbreed with Neanderthals, or that Neanderthal DNA that we share was present in the ancestor of modern humans and Neanderthals, and we inherited a bit of it. Neanderthals inherited most of it. And so there are various reasons why we might share DNA with Neanderthals. It's pretty clear to me, and I'm just really as an onlooker, I mean, I probably know not much more about this than you do. It's pretty clear to me that modern humans, likely evolved in Africa. Neanderthals were the descendants of a group of hominins that left Africa before that. Neanderthals managed to adapt to the cooler and much less welcoming climate of Europe.
Mm-hmm.
And what we need to realize is that even though Neanderthals became extinct, it doesn't mean that Neanderthals weren't well adapted.
Yeah.
And Neanderthals probably lived for longer than modern humans have lived.
Mm-hmm.
So just because we are here and Neanderthals aren't, doesn't mean that we are, we've somehow won the lottery. We're here now. I think if we were doing this interview in 200,000 years' time, then I think it would be reasonable to say that, modern humans probably lasted longer than Neanderthals lasted. Mm-hmm. So certainly I'm attracted by sort of hypotheses that relate to the amount of energy that Neanderthals needed. Neanderthals had larger limb bones. They probably had more muscle. They probably needed more calories a day to keep them going. Mm-hmm. Modern humans in general had lighter skeletons, probably needed less energy. And at times when there was an energy crunch, Neanderthals were probably at a disadvantage.
Mm-hmm. Yeah.
And so my guess is that the differences between humans and Neanderthals are small differences, but over time, small differences can make a difference.
Mm-hmm. Okay, so let me just ask you about one last topic. So we've been focusing a lot on the physical traits that different hominin species present or evolved. But then we also, in our human evolution, we also care to learn a little bit more about our behavior, our sociality, and things like that. So what would you say are some of the biggest challenges in trying to study and understand a little bit better the kinds of behaviors of different types that hominin species had?
Well, I think the challenges are to try and work out, the average brain size of a modern human is about 13 or 1400 cc's, or the endocranial capacity. What we don't, and chimpanzees and bonobos, large brain ones have brains of 300 cc's. Mm-hmm. We know what we're capable of. We know what they're capable of. Mm-hmm. The big challenge is working out what a Homo erectus with an endocranial volume of 800 cc's was capable of. Mm-hmm. And we frankly do not have much of a clue about this. The only clue we really have is the archaeological record. Yeah. And so what we're trying to do, what archaeologists are trying to do, is use archaeology to reconstruct human behavior. Mm-hmm. And so you can then ask the question, what does the archaeological record tell you about how hominins behaved 2 million years ago or 1.5 million years ago? How much, did they move around the landscape? Were they collecting raw material from, were they restricted to raw material that was in their immediate vicinity, or did they go in search of raw material that was 20 kilometers or 30 kilometers away? And so you're trying to use the archaeological record to try and reconstruct the behavior of somebody, of a few individuals whose behavior is reflected in that archaeological site. Mm-hmm. So it's a matter of scale. An archaeological site will enable you to reconstruct the behavior of a few individuals. You want to know, and I want to know, what was the capability of the species? Mm-hmm. And that's a different, you could go all over the world and you could randomly select 5 modern humans from different regions, and you could follow them for a month, and you could try and work out what they were doing, that probably is not going to give you a terribly good idea about what the species is capable of.
Mm-hmm. Yes, and I guess that you mentioned, for example, the size of the brain, and you were probably also referring to different brain areas that have evolved or increased in size over time. It's also difficult to translate that into particular behaviors, right?
Yes, I mean, there was a hope that the bumps and the hollows on the inside of the cranial vault would be able to tell you whether there was a speech area, or how big the area of the cerebral cortex that was related to processing language or to processing visual information. But basically, the more that has been learned about these things, the less able we are, I think, to use the morphology of the inside of the brain case to give us a sense of the how brains were functioning. I mean, I think we only know this in really very crude terms. And this is a challenge, and I'm not sure it's a challenge that we are probably ever going to overcome. Mm-hmm. If you're a paleontologist, you have to reconcile yourself that there are some things that you would like to know, but you can't know.
Mm-hmm. Yeah.
There are some things you would like to know that you thought you couldn't know, but technology has helped you to know them. For example, until technology allowed us to access the inside of bones and to look at the inner ear and the shape of the cochlea and the semicircular canals, we didn't think we would ever be able to get evidence about locomotion from the ear, from the inner ear. Now we can. But I don't think, there's always a danger. It's, just because I don't think it doesn't mean it's not going to happen. I'm not sure that we're ever going to know as much about how their brains functioned as we would like to know.
Mm-hmm. Okay, so Dr. Wood, let's end the interview on that note. Just before we go, would you like to mention some places on the internet, for example, where people can get in touch with your work? There is a web page at the George Washington University website, and the very short introduction to human evolution. I think the Oxford University Press, if you go to their site, there is information there. And there are, of course, recordings like yours, and I congratulate you for your efforts in assembling some very distinguished scientists, in which I'm not including myself, but and so we thank you for doing that. And I think conversations with scientists, and if you go to the internet, there are conversations with me that were recorded, and I've long forgotten them. It's really interesting to I think for students to hear people talk. It's one thing to read their papers. It's another thing to hear the sound of their voice. And there are some recordings made by the South African Broadcasting Service of Raymond Dart and Robert Broom. Mm-hmm. And to hear Raymond Dart's voice, he was a very famous South African paleoanthropologist, just it makes the hairs stand up on the back of my neck. So I would suggest that if you just Google anybody whose papers you're interested in, you may well come up with the opportunity to see them and hear them. Yeah. Okay, so I will leave links to all of that in the description box of the interview and also to your books and the rest of your work, Dr. Wood, so that people can check it out if they want. And again, thank you for taking the time to come on the show, and it was a real pleasure to everyone and to talk to you.
Well, it was my pleasure to talk to somebody who asks really intelligent and smart questions, and I wish you well in a time, I mean, it may be apparent that we're doing this interview in a time when you are not allowed to leave your house and I'm not allowed to leave my house. And I think it should remind modern humans that we haven't escaped the natural world. We sometimes behave as if we have, but we haven't.
Hello everybody, thank you for watching this interview until the end. I've been putting out regular interviews with top academics and intellectuals from around the world and a variety of fields. And now, to keep the channel sustainable, I would really like to ask you to please pay a visit to my Patreon page and to consider making a pledge there. Any amount, even just $1, would already be a great help. And we also have links in the description box to PayPal and other places if you want to make donations there. Otherwise, and if you like what I'm doing, please share it, leave a like and hit the subscription button. Finally, I would like to give a huge thank you to my main patrons and supporters: Karen Litzke, Anne Blanchett, Pererga Larsen, Lau Guerrero, Francis Ford, Hans Fredrik Sunda, Janne Hennin and Ricardo Vladimiro, Craig Healy, Adam Kessel, Olaf Alex, Jonathan Wiesel, David Diaz, Anian Kata, Jacob Klinkby, Matthew Whittingbird, Arno Wolf, Tim Hollesy, Enrique Lenius, John Connors, Paulina Barron, Philip Force Connolly, Dr. Jerry Mueller, Herbert Gintis, Rutger Voss, Bo Weingard, Rebecca Newberger Goldstein, and Dan Demetriou, Robert Windiger, Rui Inácio, Arthur Coe, Zoop, Marco Neves, Max Bailby, Colin Holbrook, Susan Pinker, Thomas Trumbull, Bernardo Seixas, Pablo Santurbano, Simon Columbus, Jorge Spinha, Phil Kavanagh, Corey Clark, Mark Blythe, Roberto Inguanzo, Mikkel Stormir, Eric Neumann, my producers Isar Webb, Rosie, Jim Frank, Lucas Stafiniak, Elewelyn Osborne, Dr. Ian Gilligan, Sergio Quadriano, Luis Caetano, and Matthew Lavender. And finally, my executive producer, Michel Rugieski. Thank you for all.